Well, this is where the fun begins, friends. The product and quotient rule. So we're looking at, does the derivative, if I have a product of x times x squared plus 1, so I could, what I'm asking is the derivative, if I were to multiply that out, we of course know that that would be x cubed plus x. So with that derivative, by the power rule, you would know that that is 3x squared plus 1. So is that equal to taking the individual derivatives? So could I just take the derivative of x and put that as 1 times the derivative of 2x, and you go, nuh-uh. Nope, that's not the same. So there is a product rule, and you say, well, you could just multiply everything out like I did on this side. Well, no, not if I have like sine times x squared. There's nothing to do to multiply that to get rid of the product. So you have to know what the product rule is. And it's, you're going to have f, so f and g, so those are your two functions of x. You're going to do f times g prime plus g times f prime. Or in words, I call this guy the first one, this guy the second. So I say in my head, first times derivative of the second plus second times derivative of the first. First times the derivative of the second plus the second times the derivative of the first. So let's try one, and you can see how that formula is used. So if I want h prime of x, now notice that I see two variables of x. That's how I know I have to do the product rule. So I'm going to call my first 2x and my second cosine. So the derivative would be the first times the derivative of the second. What is the derivative of cosine? Negative sine. Plus the second times the derivative of the first. So the derivative of 2x is 2. Now they certainly could clean that up. I mean, they could even factor out a 2 if they felt like it, but I'm not going to do that because I know that you could. I wouldn't do that on free response. I'd only do that if it's multiple choice and they had it like that. So there is my derivative. Let's look at example 2. And it seems like, okay, well, that's not too tremendously bad till we get to example 2. And the problem with the product rule and the quotient rule is that many times once you do it, there's an algebraic step that you're going to have to do. And we did this at the beginning in our review material on the first week of school, where we practice factoring out an exponential. Now, when we get there, you'll see. Well, you certainly are not going to multiply this out. So I'm going to take that as my first and that as my second. Remember, I am able to do the power rule on these things. So here we go. First is x minus 4 to the 5th times the derivative of the second. Because the inner derivative, x plus 3, the derivative of that is 1, I can just go straight power rule. So power to the front, decrease the power by 1. So that's the derivative of x plus 3 squared, cubed. So first times the derivative of the second plus the second, x plus 3 cubed, times the derivative of the first, 5x minus 4 to the 4th. But they will not leave it like this. Here's the part, you've done the calculus part. Now the algebra is I have to look and factor out what's common. So notice that both of them have an x minus 4. Now what power could I take out? A 4, because that one has 5 and that one has 4. They both have an x plus 3, and I have to take the lower power, so that would be 2. And unfortunately, with numbers 3 and 5, I can't take out a number, but I would look to see if I could do that. Well, if I took those things out, I'm kind of like doing the distributive property backwards. Okay, when I distribute this, I should get back to this line. So I'm going to look. In this first term, I'm certainly missing a 3 because I didn't take that out. And I would need one more x minus 4 because I took out 4 and I needed 5. I took out all the x plus 3's, so in that first term, that's what I would be left with. In the second term, I would need the 5. I have all my x minus 4's, but I would need one more x plus 3. And then my last step is just to clean up this parentheses. So I'd have 3x minus 12 plus 5x plus 15. And so my final answer is going to look like this. I'm going to have this stuff that was on the outside, x minus 4 to the 5th. Sorry, x minus 4 to the 4th. I was looking up at that top line. Silly goosey. Let's erase that. So x minus 4 to the 4th. Wrong pen. I'll get it together. And then x plus 3 squared. And then what is this parenthesis simplified to? 8x plus 3. And that's the final answer that would be on the answer blank. So it does get a little bit tricky for sure, and there's some algebra in it that you'll have to do. Let's look at this next one. Kind of same thing. Now you could work this problem. Some people go, well, hey, Ms. Pruitt, I could work this out from the beginning. Like I can distribute it out so I wouldn't have a product. And you could, and I probably would do that. This is x to the 1/2. So you have x to the 1/2 times 3x squared minus 1. So what is this y actually equal to? 3x to the, you add exponents, 1/2 plus 2 is 2.5, so that's 5/2, minus x to the 1/2. So the good thing is, sweet, you go, I don't even have to do the product rule. And you're right, you don't. And I would choose to do that. So dy dx, I'm just going to go straight power rule on this. So power to the front, decrease the power by 1, so that would be 3/2, minus power to the front, decrease the power by 1, and I would get that. Now the issue is, that's not how they're going to give the answer. So you do have to look to factor. So you don't get out of that part regardless of if you multiply it out at first or not. So what could I take out? Well, with my numbers, I do have a common denominator. In the numerators, I have 1 and 15, so nothing I can take out there. But in the denominator, I have a 2 that's common, so I'm going to take out a 1/2. And then I'm going to take out x to what power? Well, in the previous example, remember we took out, if we had 4 and 5, we took 4. You always have to take the lower one. So which one is a lower number? Is 3/2 or negative 1/2? You'd say, well, the negative is the lower. So I'm going to take out 1/2 x to the negative 1/2. So what would I be missing? I would need to multiply. What do I multiply 1/2 by to get 15/2? And that would just be 15. I would need x to some power. Remember, when you multiply, you add. So I think, what do you add to negative 1/2 to get 3/2? That would be 4/2, which is 2. We'll just put 2 there. And in this one, well, gosh, I have the exact same term, so I'm just going to put minus 1. But of course, they don't like negative exponents, so all I really have to do from here is the 15x squared minus 1 would stay on top. The 2 is on bottom, and most likely, a lot of times, if they have x to a power of 1/2, they usually type it with the square root of x. But if you wrote x to the 1/2, I would give you credit. So there you go. Could I have done the product rule from the beginning? I could have. I would have a different factoring out, but you would end up getting the same thing both ways. All righty. So we are good to go there. Now let's look at the next example. Has quotients in there. So just like you can pretty much guess that the quotient rule is not going to be just the derivative of the top over the derivative of the bottom. So what do we have? This one is, I'm going to use this bar as a fraction if I can. Well, no, I won't. Yeah, I will. Okay, I'll make up my mind. So f over g is going to be g times f prime minus f times g prime all over g squared. Okay, that looks hard to memorize. So let's write it a different way. This guy is on top, so he's the high. This guy is on bottom. Now, I'll be honest, sometimes some people call that the low. You can do it however you want. Honestly, I like calling it the ho. Ho and low. Ho is just more fun to say, like Santa Claus ho. So we have high ho, or like the Seven Dwarfs, okay? We got high ho. So here's what I like to say. Ho, or low, d high, minus high d ho, all over ho, ho. I can remember that, and literally that's what I say in my head when I'm doing quotient rule every time. Ho d high minus high d ho over ho ho. And I kind of remember which order because the ho's are always at the ends there. All right? So let's do m of x. But if you like to say low better, so you can remember which one is high and which one is low, that's fine. Let's try this one. So this derivative, m of x, m prime, I literally say, here's my high, there's the ho, and let's go. Ho, x squared plus 1. D high times the derivative of the high, so that would be a 5, minus high, 5x minus 2, d ho, derivative of the bottom, is 2x, all over ho ho. The good news is they usually don't multiply out that denominator. I mean, you can, but I don't. They'll accept it if you don't, or you can look at your answer choices, but I'm not going to multiply it out. And so the last thing I have to do is just clean up that numerator. So 5x squared plus 5. Be careful. I do have a negative right here, so I'm going to think about distributing a negative 2x, so I remember to distribute to both. So that would be minus 10x squared plus 4x. All over this. And so my final answer, if I just clean that up one more step, my derivative ends up being, what do I got? Negative 5x squareds. I have 4x and 5 over x squared plus 1 squared, and this is m prime of x. So here's my derivative. So it's just a little memorization and some algebra skills. Let's do the last one. All right, last one. Write the equation of the normal line. Oh gosh, if it says normal line, I always tend to underline that because I'll forget by the time I get to the end. To that function at x equals 2. Okay, we'll try this one on your own because you should be able to do all the steps. It's the same question we've done. I just can give you now a function that has a fraction in it. So you're going to do f of 2. So when I plug in 2, 3 times 2, that would be 5. On the bottom, 2 plus 2 is 4, so my point is 2 5/4. For f prime, I'm going to do ho. And sometimes when I go d high, I go ahead and put it in front just because it looks prettier. Minus ho d high minus high, 3x minus 1. D ho, that's just 1, over ho ho. So x plus 2 squared. And this is something that's kind of a preference thing. You can clean that up if you'd like. I mean, the whole point of me doing that is to get f prime at 2. So you can choose whether you want to clean that up and get it simplified, or you can just plug in numbers at this point. So a lot of times I just go ahead and plug in the numbers. So I would have 3 times 2 plus 2 is 4, minus 3 times 2, that would be 5, over 4 squared, so that would be 16. So what do I really have there? My slope of the tangent line would be 7 over 16. But remember, I underlined, we're writing the equation of the normal line, so I'm going to go y minus 5/4. I'm not going to take this slope, I'm going to take the opposite reciprocal and x minus 2, and I'm done. So that's awesome. That is awesome. You now know how to do the product and quotient rule. We can give a little more complex problems. And so that's cool. All righty. Well, good luck on your homework. Let me give you one hint on the homework. There's some on the back where you have formulas. Like they give you f of numbers, f of 1, and g of equals this, and g of 1 equals this, and g prime at 1 equals this, and f prime at 1 equals this. Well, if I want the derivative of f times g, for example, then you need to start that by writing the formula. So you would have ho first times the derivative of the second plus the second times the derivative of the first. Now this is really f of x and g prime of x. So if you want to evaluate that at 1, you would just have all these 1's in there, and then they gave you all that information. You just fill it in and do the algebra. So you have a couple of those on your homework, so I wanted you to know where to at least start that. All right, cool deal. Peace out. This guy is on